a reptile with an elongated structure on its back. This is Longus quama. And say hello to Tranistopheus, a reptile with a neck more than half the length of its body. Typothoraxinae, a class of herbivorous reptiles, have armor on their backs. And then there's Drepanosaurus, a reptile that resembles a lizard, but has a beak instead of teeth. What all these prehistoric animals have in common is that they appeared during the Triassic period of the Mesozoic era, soon after the Permian mass extinction event, and their unique appearance have puzzled many paleontologists. Some paleontologists who saw fossils of Longus quama mistook the structures on their backs for fossilized ferns. And Hungarian paleontologist Franz Nopcsa even reconstructed a fossil of Tanistropheus as a pterosaur. And I guess it's understandable. He mistook their long neck bones for pterosaur wings, because he couldn't imagine that a reptile could have such a long neck relative to its body. So the question is, why? Why so soon after a mass extinction event did we find so many weird-looking creatures that even had the most seasoned paleontologists bamboozled? You might think, well, they're ancient animals, so of course they're going to look odd to us. But in fact, if you look at the earliest reptiles, Hylonomus, that lived during the Permian period prior to the mass extinction event, they don't look all that different from today's lizards. So what we're saying is that after the mass extinction, a particular phenomenon influenced the emergence of these unique and diverse creatures. And that phenomenon is adaptive radiation. When a mass extinction wipes out 70 to 80% of organisms in an ecosystem, it creates a vacuum, an ecological niche. The few organisms that survive the mass extinction event can quickly adapt and transform to fill these holes, the lack of competition making it easy to take full advantage of the resources available. Mutation, one of the key elements of evolution, can often pose disadvantages for survival. But when you have a lot of ecological niches with no competition, the mutated individuals have a higher survival rate. And as long as they're generally fit enough to survive, they can begin populating the environment. It's like when we first started inventing airplanes. Back when there were no airplanes at all, they varied widely in terms of design and shape. And over time, the ones that didn't work or meet the standards of the time naturally go extinct, while the ones that do remain and evolve over time. Reminiscent of adaptive radiation and natural selection in the natural world, don't you think? The rapid expansion of biodiversity in the Cambrian period, with the appearance of strange creatures, was an instance of adaptive radiation to fill empty ecological niches. And the same phenomenon occurred during the Triassic period. In the forests left empty in the Permian mass extinction event, some reptilian ancestors diverged into species like Drepanosaurus, with feet adapted for tree climbing, flexible necks, and beaks optimized for catching insects. Uniquely, they also had a stinger-like structure at the end of their tails, like scorpions. In 2016, Dr. Adam Pritchard of Yale University, who studied Drepanosaurus, said that it was a great example of adaptive radiation because it was so different from its reptilian ancestors. During the Triassic period, reptilian adaptive radiation occurred in many places other than forests and in many forms. Reptiles like Longus quama developed unique structures on their backs for showmanship or predator intimidation. And reptiles like Tanistropheus could extend their long necks to eat fish in rivers. Stepping deeper into the water, large carnivorous reptiles of the Phytosaurian order, such as Redondosaurus and Similosuchus, evolved long, powerful snouts over the course of a few million years. And this adaptive radiation made them river ecosystem powerhouses. Oh, and by the way, in case you were wondering, these guys aren't the ancestors of crocodiles. The real crocodile ancestors were much smaller and lived on land until they went extinct. Meanwhile, in another forest, herbivorous reptiles of the order Adasaurus, like Typothorax and Desmatosuchus, adaptively radiated out and filled the empty ecological space with armor on their backs. These post-extinction ecosystems were almost like giant laboratories for rapid evolution, and we can still find such adaptive radiation experiments all around us today. A prime example is the Hawaiian honeycreeper. The Hawaiian Islands are a region with many ecological niches because new islands are constantly forming. The ancestors of the Hawaiian hummingbird, which settled the islands around 15 million years ago, were initially a single species. But as they filled ecological niches in the absence of competition, they diverged into a different species, adapting their beaks to suck nectar, hunt insects, and forage for seeds. And once these ecological niches are filled, the rate of evolution usually slows down. For example, the nectar suckers find it deviates from their current role in the ecosystem. But when birds of different ecological roles go extinct, a new ecological niche opens up, which can then be filled by new species. Interestingly, this phenomenon of unique new species emerging after mass extinction events repeats itself almost like a natural law. At the end of the Triassic period, about 200 million years ago, volcanic activity led to a dramatic increase in carbon dioxide levels and the subsequent acidification of the oceans, wiping out about 80% of the world's species. However, some unique creatures adaptively radiated throughout the Jurassic and Cretaceous periods that followed, thus filling the ecological niches that had opened up. Those creatures were the dinosaurs. When the herbivorous Adasaurus disappeared, Stegosaurus adapted and took its place, and Spinosaurus grew to thrive in the rivers once occupied by Phytosaurus. Many other examples exist as well. But, as you may know, a massive asteroid impact near the closing of the Cretaceous period brought the dinosaur era to an end and opened up the Earth to a whole new roster of creatures. And the stars of this new show: mammals. Mammalian ancestors had already appeared 240 million years earlier, but during the Mesozoic era, they were largely overshadowed by the dinosaurs. But when the dinosaurs went extinct at the end of the Cretaceous period, mammals went on a massive adaptive radiation spree, filling in many ecological niches that their predecessors left behind. This was the start of the incredibly diverse array of species we still see today. As you can see on this graph here, during each of the great extinction events throughout Earth's history, a large number of organisms disappeared, followed by a large number of new organisms appearing on the scene. These creatures that appeared after these extinction events were quite different from the ones that had thrived pre-calamity. This pattern is almost a law of nature that will continue to enforce itself as long as life continues to exist on Earth. If another mass extinction event comes along, and many of today's creatures, including us, are wiped out, what strange new creatures will appear to fill in the gaps? Science is a window to the world, and this has been Science Dream. Thank you for watching.